Hello, this is presentation 8. We are going to present Monte Carlo discrete event simulation problem. I'm Shin and I'm on a team with Alana and Francisco. In this problem, we have to consider a job shop scheduling problem. It is required to schedule 6 jobs on 4 machines. Each job will be denoted by J1, J2, J3, J4, J5, J6 and have its own routing from machine to machine, which is denoted by M1, M2, M3, M4. We need to take the average time from the total time of jobs at all machines and construct the problem using Monte Carlo. Since our problem has 6 jobs and 4 machines, we set up a 6x4 matrix. We are looking at both the machines and the jobs and will need to create a nested for loop that will run through all of them. We start by initializing the time in minutes to 0, so when the code starts, it will add each iteration for the job done at the machine.
This is our problem modeled in MATLAB. As you can see, we have the job shop problem there outlined, where we have the number of jobs and machines, and then we have them basically put into the matrix with the 4 different times, and then we have the nested for loops that first choose the different arrangement of the 6 jobs that will go to the machines, and then we initialize the time, and then it'll go through it'll choose the machine and then the job, and then add that time that it takes of the job at that machine each time, and then it'll calculate the total time, and then we'll take the average of the times that equate to the total time. For this problem, we decided to use MATLAB, and here we'll just demonstrate it. So here you can see that we have the number of jobs 6, and then the number of machines 4, and then we have placed that into a matrix called jobs, and here we have the different times 20, 25, 10, and 10. Then we have our first for statement where we say I is equal to 1 to 1,000. That's how many times it will go through and iterate. And then we have X, meaning this is choosing X equals rand perm. 6, meaning choosing it will arrange the 6 different jobs for the machines, meaning that the job order does matter because we're trying to minimize the average time it takes for the entire thing to run. And then here we have initialized time as 0, and so we hear time equals time plus job chosen at that machine, and see how long it will take, and then it'll iterate through that and calculate the total time and also store it. And then at the end, we want to take the average time of all those times of each machine and take the mean and find the low average time. And we'll just hit run section to run the code and just wait a little bit for it to show the average time of the time total. We should get an average time, we get an average time of 390. From the demonstrations, we could see that the average time came out to be 390. In terms of accuracy, to make this simulation more accurate or better, we could possibly have more iterations so it can go through more thoroughly. And then also we could check the accuracy by checking the different times of the jobs at each machine, just to see like the different changes in times of the jobs at each machine and how long it takes. And the problem does try to find the best average time of the total time taken from each times. It runs through the iterations, and we can see that it gives a time of 390 for the simulation.
How can a business interpret and or use these results to their benefit? The first thing is they can look at how long it takes a job to be completed with its associated machines. So as you saw with our example, we had 6 different jobs and they had 4 machines associated with each one of those. So we can look at individual jobs and see how long they take. And then another thing a business could do is look at the entire simulation and get a total time from that and maybe use it for giving a customer an estimated time of finishing whatever project the company has been given. Additionally, the company can look at the individual machines and see if there is a problem with one of the machines, if it's taking a little bit too longer than it normally does, or something like that. So how can this technology be used in business today? Businesses can use the simulation in MATLAB to find the machine line rates, the bottlenecks, which machines take longer to complete jobs, and even which order jobs should go in to help the company be more profitable, which is what we did for our demonstration in MATLAB, as you saw earlier. Another thing that can be done is the usage of Simio, which is a 3D simulation modeling tool. That one is very helpful in getting a more visual representation of what's going on inside of a company. Another great example that is great with Simio would be the penny fab problem. And that one, it's showing a lot of different things, as in the throughput, critical whip, the cycle time, and even like the queuing size that is possible, and how much money would it will cost you to have so much product inside of whip and all of that. So this type of technology is great for projecting things that a company is not yet sure will work for them and finding the best solution before implementing something that may cause them to lose money. It helps in reducing the amount of possible errors that they might have.